Hi class, we're going to do Chapter 17 now, and this one talks about stars and how they live their lives. So we've talked about how they're created, how they're born, and all the different kinds of properties that we see of stars. But how do they, once they're sort of done living their lives, how do they actually end up dying? So the goal for this first part is just thinking about mass and how mass affects the amount of time a star burns nuclear fuel in the core and then eventually starts dying. So if we look at the HR diagram, our sun kind of falls in the middle here. And we'll talk about these different stages in the next part. But we want to think about mass and how mass affects what happens to a star. These are low mass stars down here. These are high mass stars up here. Just very basically, what are the differences? So if you have a lot of mass, then you have a lot of gravitational force squeezing the core. It makes the core much hotter. So the temperature is much higher. The fusion reactions can happen much more rapidly. There's many more fusion reactions per second because it's so much hotter and also much denser because gravity is squeezing everything. So the more massive stars, they might have a lot of mass, but they use their mass, they burn their mass, they burn that hydrogen much faster than a low mass star. And another important thing that we'll see later on is that in the low mass star, the inside of the star is all convective. The star is kind of mixing itself up all the time. And so the fuel that it uses is not just what's in the core initially. It ends up being able to use all of the fuel in the entire star. So a lower mass star isn't as hot, and so it doesn't burn the fuel as rapidly. And it also uses all the fuel that it has, so it can live a much longer life, even though it doesn't have as much mass to begin with. High mass star, again, lives its life very quickly because it burns its fuel very rapidly, and it doesn't have that kind of convection inside to mix everything up, so it only can use what's in the core. It can't use the vast majority of the mass that it consists of. So if we add mass then to the HR diagram, as we've seen before, we're going to break these stars into three categories. We've got what we call low mass stars, all these stars from the lowest mass, 0.08 times the mass of the sun, to about 2 times the mass of the sun. We're going to call those low mass stars, and our sun is technically a low mass star. And we break things into these groups because they die in a certain way. These stars die in kind of the same way. And then the next group is intermediate mass stars, and that's between masses of about 2 times the mass of the sun to about 8 times the mass of the sun. Those stars die in a different way than the low mass stars do. And then we have high mass stars that are just kind of, on average, sort of 8 times the mass of the sun. This number 8 and the number 2 are not necessarily exact dividing lines, but roughly 8 times the mass of the sun is what we'll call a high mass star, something greater than that. And the way the high mass stars die is quite different from how the low mass stars die, and we'll talk about those differences. So what we can see, the way we know what we know, is that we can look at models, computer models, based on how we understand gases and nuclear fusion and things like that. And we can compare that with star clusters. When we look at a star cluster, we are looking at a bunch of stars that are formed at about the same time, and so they all have the same age. And we see a variety of different types of stars, some stars that have already died, some stars that are in the process of dying, and other stars that are still well in the middle of their lifetime on the main sequence. And so by seeing the variety of stars all about the same age, we can understand kind of how stars die by looking at young stars versus old stars and whether what we see matches our models or not. So that's pretty much it for this first section. Just talking about mass and how it affects the death of a star. Again, the really high mass stars are much hotter in the core. They burn their fuel much faster. They don't live as long. Low mass stars are not as hot. As long as they have enough mass, they can still burn hydrogen into helium. They can still do nuclear fusion, but they just don't do it as fast, and so they live much, much longer. In fact, the lowest mass stars, the lowest mass stars that have ever been formed in the universe are definitely still alive. Not a single one of them has died yet, because they live for many billions of years, maybe 100 billions of years for the lowest mass stars. And we think the universe is only about 14 billion years old or so. So those stars are all still alive. So in the next section, we'll talk more specifically about these low mass stars from about 0.08 times the mass of the sun to about 2 times the mass of the sun. How do those stars end up dying once they run out of hydrogen in the core, what happens? What do they go through? What kind of process do they go through?